Hello, I am Rongfan. Here I am going to introduce you to my wine product quality evaluation project with techniques that we learned in class. In this video, we're going to go through crisp DM data mining. We'll cover data cleaning and preparation, data visualization, so that we can have a clear mind of what the datasets look like. Then, we're going to go through the principal components and follow with our regression models, including linear regression, logistic regression, naive Bayes regression, random forest classifier, and SVM. Let us first look at our datasets. It is all numerical with 12 columns. So we have some chemicals, contents related to the wine product, and the quality, which is what we are interested in here. Then we will start with our data cleaning and preparation. So first, I filled all the names with the mean of all the columns so that it won't have so many missed ones. And then I check for our null cells. There is none. Followed by that, I check for the null values. So the entire dataset has 4898 samples, and it's lucky to see that there is none null in this large dataset. So we are good to go to the data visualization. Since we know the column of density is dependent in a few columns, several data visualizations is focusing on density. So here is the scatter plot for the alcohol contents of density. So we can tell as the density of wine goes higher, the alcohol percentage is getting lower, and regular density is close to the density of water but slightly around it. Also, a box plot for density itself is plotted to check its own outliers. So we can tell it's only 3 out of 800 of samples, so it is pretty good. Then we have some histogram and pair plot to see if they have some collinearity. We don't see a specific patterns here, so we do not refer to this graph to say they have a collinearity. From this histogram, we can take a look at those count for quality scores. So quality scores of 6 is most common, like higher than 2000 samples. The smallest appearance rate is scored about over 8 or below 4. We can say that the quality is medium level in this sample set. Then we go for a lot of box plots. We don't go through the box plots in detail in the video because we have limited time. So we can see this box plot have a lot of outliers. So we take a closer look at the description of our data. So we can tell the fixed acidity that from 25% to 50% is changing from 6.3 to 6.8, that the range is not too wide, as the variance is not significant. So it could explain the huge number of the outliers. For residual sugar, the minimum was changing from 0.6 to 65.8. That's a huge amount. So that can explain for a huge number of the outliers. Then we want to classify the quality so that the customer can see more straight level of the wine they're looking at. So here, it is divided into 3 groups and fit into a new column, quality level. Due to the quality scores we have, the data was divided into quality score less than 4 to not that good. 4 to 6 is an average, so we assign to 2, and 6 to 10 is 3. So here we are predicting 12 columns, but we first use the principal components to pick our 8 valuable components that we are actually looking at a 90% here. So the first one going up to 90% is around here, so it's totally 8 points. We're going to use 8 components for our principal components. In our first regression model, that is linear regression, we do not see it perform really well, and we do not like the cross-validation score here. Also, in previous tests, we have a really low R-squared. So let's look at our another regression model, that is logistic regression. Well, this one we can tell it shows a lot better accuracy at 96.816 of accuracy, and the cross-validation shows it does not have an overfitting issue, that none of those numbers are different to each other a lot. Also, for the decision tree, we have 95.26 of accuracy, and it also does not have an overfitting issue, we can tell from here. And then we go to the naive Bayes. It do have a high accuracy too, 96.4, and it do not have any overfitting too. Then the random forest. The random forest, we have a really high accuracy as 100, and it do not show any overfitting problems here too. Then is our SVM. It shows better SVM in linear and 97.9 accuracy. So here is all of my coding, and the best model I like is the logistic regression, that with 96.8 of accuracy, and it has a really low cross-validation value. I wish this project can give a good start for the long-term project and the proposal of my wine products review. Thank you.